doing a lab today. Good. So I'm going to model this, but before I do that, I'm going to pass these out for you guys. Last week we went over how to find the amount of neutrons, protons, and electrons in an atom. And so this just gives you the answers to it. So this is a model of an atom. Everyone see this? Tyler, can you see this? Okay. So for our first atom, for our first element, everybody look at hydrogen. So hydrogen has one electron, which is right here, and one proton, which is right here. Everyone understand that? Understand that these are two different areas of an atom. Yeah? So I'm going to go into helium. So for helium, you have to have two electrons, two protons, and two neutrons. Do y'all see that on your paper? So this would be an example of a helium atom. Okay, so what would I do for a lithium atom? What would I change?
Add a proton.
Awesome.
Add a proton.
Add a proton, okay. Does that make a complete lithium atom? No? And Elise, what would you do?
To add another electron.
Add another electron? Taylor,
Add a neutron.
add a neutron? Tyler, is it done? Or do we need to add something else?
Another neutron.
Another neutron? David, do we need to add anything else to this?
Okay, we have 3 protons, 3 electrons, boom. 4 neutrons.
Mm-hmm.
No, we're finished.
Are you sure?
I'll leave it for the list. Oh, well, we need to add an electron. Oh wait, lithium? No, yeah, I'm finished.
Yeah, you're good. Just double checking to make sure you understood. Good job, guys. So this is what a lithium atom would look like. Y'all get that? Okay. Go ahead and materials managers, grab your trays. Over on the side. Okay, so okay, so for today's lesson, we need to be careful. We have pipettes, and pipettes are very strong at the end where they'll poke you. They're very sharp, very strong. Don't put the pom-poms in your mouth, in your nose, or in your ears. Do not eat them. We do not eat science objects. Okay. So electrical charges do not have color. The pom-poms are all different colors. They have plus, a 0, or a negative on it. So what do you think the plus represents? Taylor.
Proton.
Okay, and Elise, what do you think a negative represents? And Alexis, what do you think the 0 represents? A neutron. Good job. So first we're going to make hydrogen together, so go ahead and get them out. And you're building these as a group.
Right, so
Anything hydrogen?
is one proton, one electron.
Oh, bam. Bam.
Zero neutrons.
It just says zero. In my
Oh, this
head,
is
I
the
saw a
minus.
zero, so I almost.
This is the electrons in the cloud.
Yes,
How do I know this? Because I didn't make a test. And I was in my previous class.
Helps if you turn the power on.
He's partially loose.
Alright, so everyone can see this? Yes? So as a group, you guys already made them. We're going to make hydrogen first. So hydrogen would have a positive in the middle and a negative on the outside. So go ahead and draw all that on your sheet.
Oh, shit. Oh, oh.
I see a few of you are drawing them different ways. The way I would like you to draw it would be like this. So that these aren't touching. Okay, so to do a helium, we would add just 2 neutrals and 1 electron. Go ahead and draw the helium. Okay, Sarah, how would I draw lithium, or how would I add to lithium?
You would add 2 neutrons in the center, a proton in the center, and another electron.
And how did you get that?
I looked at the numerical list of atomic numbers of elements.
Alright, go ahead and draw that then. There it goes. Okay. So, for the next 4, I believe, you are going to do them on your own as a group. You can talk, discuss, figure it out, how you think the next one should work. You should find a pattern in between them and figure out what that pattern is.
Lithium. Another one. Lithium peroxide. And this says lithium has 4 neutrons. So 2 more. And 3 electrons. What the? But the protons and the electrons are equal.
Forgot to set your timer. You have 7 minutes to do this.
Alright.
Are y'all working together? 'Cause y'all
With
are all
proton?
on different ones. You know what together means?
More weights.
No.
Which one is this? Beryllium.
It should be 4 electrons. Just 1 neutron?
Yeah, that's right. Neutron.
Electrons and protons seem to have the same number.
They change. Six, positive 6, neutral 6.
They have 5 neutrons in those?
We're on beryllium.
There's 5.
Oh, yeah, I'm looking at atomic number, not. I was looking at the 4 under atomic number,
Oh, I see.
so that's where I done messed up. Alright,
Atom number in neutrons. Has 7.
So for boron, for our next one, boron has neutrons.
And then,
We should have 5.
we're just going up 1 proton and neutron, electron every time.
See, Austin's found a pattern.
Neutron, they're just whatever they want to do. Oh, we have 5 right now. Just 2 neutrons.
Seven.
Pardon? Yeah. There's lots of those. Looks like neutrons just do what they want. Okay, so we're adding 1 of each then, but no neutron? No neutrons stay? What are you going back to? Because we always add protons into electrons, like check for neutrons.
That's what we just cancel.
There's 8 protons and neutrons for oxygen.
Yep. So, bam, but what's our,
You guys finished?
Yes.
I don't think so. I see
And
some
oxygen looks like we
questions
just gained
unanswered.
one neutron.
Why don't you discuss them like you're first?
Eight, it's eight, always eight.
Neutral, negative.
Oh, the neutrons are positive.
Protons and electrons go up one every time. Based on this thingy.
Please do not throw phones, guys.
Hit the ball.
Why don't you put them back in their baggies so you aren't wanting to throw them? Or hitting them. This is a lab, not a baseball field.
Material.
I have about 9 minutes or 2.
What is what? I realized we were answering these. I think we are, I just didn't realize it. What else did we say, protons and electrons always the same, it goes up by 1?
The table of elements that you have, the periodic tables, those are for you guys to keep, to use. They're the periodic table that they use for the STAR test. Yeah, that one. That one.
Well, that's what I was saying. I was like, wow, they really don't have to know anything.
No. That's for the STAR test. Okay, so questions. What pattern did you notice, Kristen?
The protons are the same number as the electrons.
Protons are the same number as electrons? What's your evidence for that?
So that's what it says on the paper.
Okay. What about Alexis? What did you notice? What pattern?
I noticed that the number of neutrons are equal to the mass number minus the protons.
Okay, good job. Tyler, what did you notice?
As the element goes up, its atomic number, the protons and electrons increase equally.
Okay, each time? Okay. So let's see. So the same amount of protons and electrons, and then there's a different amount of neutrons, and then the atomic number increases by 1, so do the protons and electrons, which is what you guys got. So what do you think that the circle represents? Sarah.
The atom.
Represents the atom, the whole atom? Okay. What about Austin? What do you think the circle represents?
The nucleus.
Nucleus? What's a nucleus?
I don't know.
We'll get to that today. Don't worry. So the circle is a central location for the protons and electrons, right? And he named it as the nucleus. Someone's learned about this before. So, in your own words, Taylor, how would you describe a nucleus?
A space that holds protons and neutrons.
Okay. And so what are or where are the electrons? Alexis?
Outside the nucleus.
Outside the nucleus? Correct. So this is called the electron cloud, the area outside the nucleus. Okay, so I'm gonna pass these out. Pass that down, take one, pass it down. Pass it down. Okay, so y'all were working with positives, negatives, and zero charge. Y'all were saying that the positive was called what? What were y'all saying the positive charge is called? Okay, so now y'all can write that down on y'all's explanation guide. Write down the definition. Who can tell me what an electron is? Sarah?
A negatively charged particle?
Yeah. So write that one down too. And then Austin, can you tell me what a neutron is?
A neutral particle.
Yeah, good job. Oh, sorry. Okay, so this is a picture of an atom, basically like what y'all were working with the pipe cleaners and the little pom-poms. In the middle here are the neutrons and the protons. And then on the outside are the electrons. And the pipe cleaner, let's say that this was the pipe cleaner, it represented the nucleus, right? Which holds the neutron and the proton. And then where the electrons are, it's located in the electron cloud. Okay, so. Okay. Well, in your own words, can you tell me, let's see, David, can you tell me what an electron cloud is?
Yes. An electron cloud is the space outside of the nucleus of an atom where electrons are.
Yeah. And, and Taylor, can you tell me what, in your own words, what a nucleus is?
The space where protons and neutrons live.
Yeah. Okay, so can y'all write down the definition, please? Electron cloud is describing where the electrons are when they go around the nucleus. And then the nucleus is the central part of an atom that contains the protons and neutrons.
So now what we're gonna do is do the word wall. First what we're gonna do is in the nucleus. Do I have a volunteer who would like to put in the nucleus where they think the nucleus is located on the word wall?
Cool.
You see there's a half circle. Where do you think in the nucleus?
So that
Yeah.
is in the nucleus and that is outside the nucleus.
Yeah, there we go. Good job. Okay, now do I have another volunteer who would like to put in the electron cloud? And this is the nucleus. Let's do it more. There we go. Okay. What two charges are in the nucleus again? Okay, so who would like to put both of these up there? And it's gonna go on the left side, inside the nucleus. Okay. Now, can I have another volunteer on putting up electron? Any volunteers? Kristen, I know you already went, but electron's going to electron cloud. Good. Okay. Now we have three charges, negative, positive, and neutral. Who wants to match these up to its name? Okay. You're gonna put them right beside their name where you believe it's gonna go. So if you put this with neutron. Negative goes to electron. Good. Okay. And then all of these just say charged particle. And there's only three spots left. So who would like to put these up? There we go. Good job. Okay, so inside the nucleus is the proton and neutron. A proton is a positively charged particle, and a neutron is a neutrally charged particle. And in the electron cloud are the electrons. And an electron is a negative charged particle. And let's see if we got that right. We did. Yay. Okay, so now what you're going to do is draw a diagram to, what's that say? To show where each is located. So basically like what we did on the word wall, you're just going to literally write proton where it belongs, neutron, electron cloud, and nucleus. Okay, looks like everybody's finishing up. Okay, good job. Okay, so now we're gonna do a human atom model. So every student is gonna be assigned a positive, neutral, or negative charge. The first group is gonna need one positive and one negative charge, so we're gonna be making a hydrogen atom. The positive person stays inside the hula hoop, They can either wiggle, bounce, dance, do whatever, but they have to stay inside the hula hoop. What do y'all think the hula hoop represents? Exactly. Can you say that a little bit louder?
The nucleus.
Yeah. Okay, and so the negative person walks around the hoop while twirling. So then the next group is going to need 6 students. We're going to be making a human helium atom. So we're going to need 2 positives, 2 neutrals, and 2 negatives. The key rule is that the positives and neutrals have to stick together. Okay, so we're going to go outside in the hallway because we don't have enough space here, but y'all need to be respectful to other students learning and try not to be too loud. Okay, let me grab the hula hoop real quick.
It's being negative now.
So like below. That makes me positive.
Okay. So, okay. Pass these down, please. Okay. Everybody got their charge? All right, let's go out into the hallway. Actually, y'all should bring y'all's little chart. I'm sorry. Yeah, with the charges, just in case we don't forget. Okay, so since we're going to be making the hydrogen, we need 1 positive and 1 negative. Okay, so negative, just walk around. Walk around at least 3 times.
Okay. 2.
Show everyone that I'm positive.
3. Okay, good job. Okay, so what does the hula hoop represent again? One more time.
The nucleus.
Yes. Okay, you can step out. Okay, so now we're going to be making the next atom, which is what?
Helium.
Yeah. Okay, how many positives does it need? How many protons?
2.
Okay, so can I have 2 positives go in the middle, just in the middle of the hallway? Stick together. And then how many neutrals does it need? 2. Okay, so can the neutrals get right up next to the positives? How many electrons does it need?
2.
2. Okay, so the remaining 2 just circle around the nucleus. Go at least 3 times around.
Should specify what direction.
I mean, I'm in a cloud.
Okay, good job. Okay.
I guess like I saw one kind of in the corner. And I was,
Okay, now we can go back inside the class.
like I counted 2, and then like I looked and what was right here, so I was like,
You saw one coming around the corner.
yeah. And I just kept counting.
Okay, materials manager will actually pick up the charges and pick up all console already did that. And can y'all put that back over on the counter, please? Okay, so I'm gonna pass out those exit slips. Make sure y'all put those names and number on them, please. gonna do is y'all are gonna first draw a diagram of an atom, and you're gonna use proton, neutron, electron, electron cloud, and nucleus, all the science terms that y'all learned today. And then the second one is going to be, you're either gonna write a 3 to 5 sentence summary on how an atom is structured, or you can be creative and write a little 3 to 5 sentence short story on how the atom is structured. Y'all have 5 minutes.